You're about to view a demonstration of the power panel Cat56 DVM. You will see the power panel continuously scanning, looking for devices or voltages and reporting what it finds. Let's take a look at the power panel continuously scanning. Before we get into the demo, let's take a moment and discuss who uses the power panel. Cable installers, when extending networks, make sure that the line is dead first. Installers of VoIP phones and surveillance cameras verify what equipment is on the line before they connect. And if their device is powered by Power over Ethernet, that the PoE is available and responding properly. Users of test equipment to guard their expensive testers from high phone voltage or Power over Ethernet. An IT manager to check what's on the unused network jack. In fact, the use of the power panel DVM is so broad that if your job is to maintain equipment or install new equipment, the power panel DVM will become your favorite tool. Now, if all of this makes the Cat56 cable sound like a crowded environment, it is. Whether it be data, phones, voice over IP, security cameras, or the latest IEEE 802.3AF standard, which provides for powering devices directly over the Ethernet. That's right, you heard me correctly, powering devices directly over the Ethernet by placing 48 volts on the same pairs that transmit and receive data. In fact, take a look at this Cisco 24-port switch. These 4 ports on the left are capable of power over Ethernet. How does the power panel Cat56 DVM help with all of this? Take a look at the following demo. This is the Cat56 power panel DVM. It is the only product in the market that can tell you what is on a network cable. Whether it be data, phones, cameras, power, or all of these, it will be displayed on the power panel DVM. We call it a DVM, a digital voltmeter, because it is very similar to a DVM. But this DVM is designed specifically for a Cat56 cable. Notice when I power up the power panel DVM that all of the elements lit on the large LCD display. You could clearly see the DVM digits. Let's try that one more time. Power down. Power up. After the little self-test period, notice how the power panel starts continuously scanning the Cat56 cable. Now, let's take a look at the power panel performing some typical tests. Let's say my job is to go out and see if a wall jack is connected to a network. I want to hook up a computer to that wall jack and I want to make sure it is live. In this case, it's a Linksys gigabit switch. Connect the Cat5 or 6 cable to the power panel DVM. I'm going to plug it into this Linksys gigabit switch, and let's see what I found. The power panel immediately tells me that it found a network device by lighting this ultra bright LED. Now, the ultra bright LED does not show up too well on video, so hopefully you can see it. It also notifies me that it sees the transmit pulses from the switch on 1-2 and on 3-6, and that this switch is capable of 10, 100, 1000, half and full duplex. Now let's say when I arrived to test this switch there was nothing. It was unpowered. I'm going to pull the power plug on it. And notice that the network light goes away and the power panel is just idly scanning the cable. Now when I plug in again, the network light is back on and the power panel sees the link pulses. Let's try another job. Let's go to another device In this case, a 24-port Cisco switch. Our job here is to plug in a voice over IP phone and get it working, or maybe a surveillance camera. There's two things we need. We need a switch that's capable of 100 megabits a second for this job, and this is a device that is powered by power over Ethernet, so we want to make sure we have available power over Ethernet voltage. Let's go ahead and plug into port 20. Oh, we timed out. Let's go ahead and power back up. What do we see in port 20? Well, we see a network device. It's flashing, so that means we aren't quite clear what kind of network device it is. That usually means it's some kind of managed device where somebody has used some software to force the port to a particular configuration. To get it to talk to us, we're going to talk to it first by forcing some link pulses down the line. By holding that down, it now tells us that it's transmitting on 1.2, and this particular port is capable of 10, 100, half and full duplex. As soon as we release the force link button, notice how we go back to scanning again. Well, we know the port can meet our 100 megabit a second speed requirement, but notice no power. So let's go ahead and try another port. Let's try port 4. Now, we know that this switch has 4 ports capable of power over Ethernet because they're labeled over here. Let's try port 4 and see what happens. Port 4. Well, just like port 20, it finds the network device. No problem there. Let's see what speed that network device is. 10, 100, good speed, but notice, no power over Ethernet. Now why is that? We're plugged into one of the 4 ports that says it's power over Ethernet. Well, that's because somebody used Cisco's managed software to shut off the power to this port. Let's try this time port, let's see here. Let's try port 1. Well, let's see how fast port 1 is. Port 1 is capable of 10, 100, half and full duplex, but still no power. Well, let's try port 2. The PoE LED lights, finally a port with power. Let's try the speed first. 10, 100. Hey, we got the speed here. It says we have power, so let's select the power screen. We found a PoE N-span device. Notice it's telling us it's sending a low voltage, 10 to 20 volts, out on 1, 2, 3, and 6. Many of you will recognize those as a data pair. Data pairs, and indeed the standard does allow for PoE right on top of the data, and there it is. It's sending out a low voltage discovery voltage to see if anybody needs power. Well, we do. Let's see if we can trigger the full 48 volts of PoE. I'm going to push the test PoE button. There it is. We looked like a camera or a voice over IP phone, and we triggered the 48 volts out of the Cisco switch. So now that we've tested this, we know that we both have speed and power, and our job is done. Now, not all PoE devices act so civilly. Some of them always have the 48 volts to start, and they're pretty dangerous devices. Others like this, however, behave according to the standard. So if all of this makes it look like a Cat 5/6 cable is a very crowded environment, it is. And that's what makes the Power Panel DVM so indispensable. Now, the power panel is available 2 ways. You can buy it in the clamshell package as part number PoE 1000, or you can get it packaged in with our real-world certifier. We call it the Cable and Power Test Kit. This is the only kit that can test your cable, your devices, and any power that might be on the cable. The part number of this kit is CPK 1000.